We're going to revisit parts of a graph, such as the turning point, maximum value, minimum value, increasing and decreasing intervals. So let's just make sure that we understand what all of those terms mean. So what a turning point is. A turning point is the location of the graph. It's the location where the graph goes from increasing to decreasing and vice versa. So the location where the graph changes, okay, that means changes from increasing to decreasing and vice versa. It can go from decreasing to increasing. The maximum value is the largest y value. So the largest y value of the range. And the minimum value is the smallest y value of the range. And then the increasing interval is where x is increasing, then f of x is also increasing. So the increasing interval, as x increases, then f of x increases. It's where the function is increasing as x increases. And the decreasing interval, as x increases, still as x increases, then f of x decreases. Now the increasing and decreasing intervals, this right here, these intervals are all about the domain. So it's all about the interval of the domain. Okay, the interval of the domain. So for this graph, let's find the turning points, the max value, the min value, increasing interval, and decreasing interval. So let's find those turning points first. The turning points are going to be where the graph turns. So it's going up, 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 and then it turns down, down, down. Okay, so we also call those maximums and minimums. So local maximums and minimums are turning points. Local max and mins. Those are also called extrema. Okay, so relative extrema. So you might see that terminology. I like to say local max and min because you can see, local to a certain area. So our turning points are going to happen at 1 to negative 2. 1, 2, 3, 4. Negative 2, 4 is a turning point, and positive 1, negative 2 is a turning point. Now our max value, there is no overall max value because this graph is going up forever. However, it has a relative or a local max. It has a local max at y equals 4. It has a local maximum at y equals 4. And it doesn't have a minimum value because it's decreasing forever, but it does have a local minimum. A local minimum at, did I say x equals 4? I meant y equals 4. Hopefully I said y equals 4. It has a local minimum at y equals negative 2. So y equals negative 2 because maximums and minimums are y values. Now the increasing interval, increasing, our graph is going, I like to think of it just drawing it from left to right, and when my pencil is going up, that's when it's increasing, okay? So it's increasing along the x values of negative infinity until I get to that turning point. And then it turns and it starts decreasing. So it's decreasing from one turning point to the next turning point. And then it turns around and it starts increasing again. It's like a roller coaster. So the interval on which it is increasing, the interval on which it is increasing is negative infinity until the x value of the turning point. So negative infinity, and then the x value of this turning point, negative 2, 4, would be negative 2. Now it's going to be an open interval, always, always, always an open interval for your increasing and decreasing intervals. But it's also increasing. This other turning point was 1, negative 2. So at x equals 1 to positive infinity, that graph is going to be increasing. The decreasing interval is the interval in between. Right here, see, the interval in between. Let me do this in purple. Right there. So the interval in between would be from negative 2 to 1. So let me just show you something really cool here. I'm going to move this over just so that you can see. Look, I'm going to put that in the middle there. So there's all your real numbers, right? From negative infinity to negative 2, negative 2 to 1, 1 to infinity. What's happening at negative 2 that negative 2 is not included? It's a turning point. I'm going to make this in black. Look, it's a turning point. What's happening at x equals 1 that is not included here, right? What's happening there? It's a turning point. Now, negative 2 to 1 is a decreasing interval where these two intervals, negative infinity to negative 2 and 1 to infinity, is where your graph is increasing, where your function values are increasing as x increases. Now, the average rate of change, we've done the average rate of change in earlier algebra classes. Typically with a straight line, we think of the average rate of change as being the slope. And that's what this formula is here. It's the slope formula. It's the change in y over change in x. F of b minus f of a, those are your y values. F of b is a y value. Okay, b, f of b. There's your x value, and there's your y value, your x and your y. A, f of a. Okay, here's your x value, here's your y value. So we've got f of b minus f of a over b minus a. That's your change in y over your change in x. Now, on a straight line, your change in y over your change in x is going to be constant. No matter what values you pick, what ordered pairs you pick on your straight line, you'll always have the same slope. But when we're talking about a curve, your average rate of change varies. For instance, if I were to find the slope between these 2 points, I would get a negative slope. If I found the slope between these 2 points, I would get a positive value. If I found the slope between these 2 points, I would get a value of 0. There is no change in y. So it all depends on the 2 points that we're looking at. What values, what x values are we comparing? Graphically, let's look at this. So let's look at this graphically. I like the graphical representation before we start working with numbers. so that you can see what's happening. Let's look at what's happening from 0 to 2. Okay. So from 0 to 2, that means from 0 to 2. What is our change in y? Well, graphically, we could see that our change in y, there is no change in y. So this is going to be 0. But this is what we do. We put a 0 in, we put a 2 in. So this 0 is an x value. This 2 is an x value. When we put 0 into the function, we get a 1 out. See this point right here? 0, 1. When we put 2 into the function, we get a 1 out. Now we find, between these 2 points, we find the rate of change. What's your change in y? 1 minus 1 is 0. What's your change in x? 0 minus 2 is negative 2. Your change in y over your change in x is 0 over negative 2, which is 0. So on the interval from 0 to 2, we have an average rate of change of 0. Let's look at from two to 4. From x equals 2 to x equals 4. Well, when x is 2, we have a 1 for y. When x is 4, we have a 4 for y. So our change in y, 1 minus 4 is negative 3. And our change in x, 2 minus 4 is negative 2. So our average rate of change is negative 3 over negative 2, which is positive 3/2. So our average rate of change on that interval from 2 to 4 is positive 3/2. Sometimes we're just given the function. For instance, in this example right here, f of x equals x squared, we want to find and compare the average rates of change on the interval negative 2, 0. So our first step is create ordered pairs. This is your x1, this is your x2. So we're going to want an x1 and a y1. We're going to want an x2 and a y2. So x1 is going to be negative 2, x2 is going to be 0. So there's my ordered pairs with my x's in them. How do I find the y values? Well, f of negative 2, f of 0. How do I figure out what f of negative 2 is? Well, f of x is equal to x squared. So f of negative 2 is going to equal negative 2 squared, which is 4. So f of negative 2 is 4. F of 0 is 0. Our average rate of change is our change in y. 4 minus 0 is 4. It's our change in y. And our change in x, negative 2 minus 0 is negative 2. So our average rate of change is equal to 4 over negative 2, which is equal to negative 2. Okay, let's try another. On the interval from 0 to 1, I'm going to rewrite the function f of x equals x squared. On the interval from 0 to 1, our first step is to create our ordered pairs. So we're going to have an ordered pair with x being 0 and an ordered pair with x being 1. Those values came from the interval. Now I have to figure out what f of 0 is. I'm going to come over here to the side. F of 0 is equal to 0 squared, which is 0. So this value goes right there. Okay. F of 1 is 1 squared, which is 1. That value is going to go right there. And then your average rate of change is equal to your change in y over your change in x. So you can take 0 minus 1. Let me use a different color right here so that so you can see it. I can take 0 minus 1, and then I'd have to start with 0 minus 1. I'd have to start with 0 in the numerator, 0 minus 1. So 0 minus 1 is negative 1 over negative 1, which is positive 1. So our average rate of change would be 1. Okay, you go ahead and try this third one. Find the average rate of change on the interval from 1 to 2 of f of x equals x squared. Press pause and then come back when you're ready to reveal the answer. Okay, I got the ordered pairs 1, 1 and 2, 4. And then your average rate of change, I'm shortcutting those letters there. Average rate of change is, I'm gonna 4 minus 1. I'm gonna start with the second ordered pair. 4 minus 1, then I'm gonna have to start with 2 minus 1. We're just using the slope formula. That's equal to 3. So if you got a 3, once again, give yourself, a pat on the back. Now, let's compare the ones on our screen that we can see. Let's compare the average rate of change of 1 with 3. This average rate of change is much faster, larger than 1. So as your average rate of change gets larger, that means it's increasing. The function is increasing much faster. Now, when you have a word problem, we need to keep in mind that there's words that go along with the average rate of change. You can't just put a numerical value in there. So on this graph, we're talking about time in seconds. And our outputs is distance in feet, right? Distance in feet. I'm just going to put distance in feet. There, we'll know. So this function, s of t equals 16t squared, this function relates the distance and the time for an object falling in a vacuum. Here t is measured in seconds. We've labeled our x-axis in seconds, and s of t, which is our vertical axis, it's in feet. Time equals 0 corresponds to the instant that the object begins to fall. Calculate the average rate of change from t equals 1 to 3. So the first thing that we're going to have to do is we're going to have to create those ordered pairs. So t equals 1, t equals 3. And now we're going to have to figure out what those corresponding y values are. When t equals 1, our output is 16. And when t equals 3, our output is 144. Now, graphically, you can say the change in y over the change in x, or we can do this numerically. So we can say 144 minus 16 over 3 minus 1. 144 minus 16, I believe, is 128. 128 divided by 2, we would think, oh, this is 64. But the problem with saying 64 is that we've got words associated with this. So 128 was a change of 128 feet. And 2 was a change in time, that was 2 seconds later. So 128 feet over 2 seconds does indeed reduce to 64 feet every 1 second. And that's your average rate of change from time equals 1 to time equals 3. You must label your numerator and your denominator. Now in the next video, we're going to work with a function, and then we're also going to take it a little bit further into talking about the difference quotient. So I look forward to seeing you in the next video.